pick numbers. As my mom used to say, you can pick your nose, you can pick your friends, but you can't pick your friend's nose. But you can pick numbers. She didn't say that part because that would have been weird, but right now it's relevant. So pick numbers. Pick numbers is a strategy for algebra problems that allows us to not actually have to do algebra, which is nice. What it does have us do is pick a number out of our brain and plug it in for a variable. So examples of problems we would use this for, anything that has variables in the answer choices. So it'll be easier if you can pick a number to plug in for those variables. And also what we like to call even-odd questions, which is categorizing numbers, variables into categories like even and odd. And you want to pick numbers for those too, even if there are no variables in the answer choices. Here are some tips. First off, you want to think simple. So pick simple numbers. Often that means single-digit numbers. It almost always means integers. Sometimes it'll be easier to do, a multiple of 10, something along those lines. But simple, anything easy to work with. You want to avoid, 17/14 or something. And you want to think smart. So let's say there's a problem that says Jeannine has to give a third of her intelligence to Alex because he could really use it.
Wow, Christmas is coming early this year.
So you want Jeannine's original intelligence to be a multiple of 3 since I'm going to be giving away a third, which is fine. I can spare it. I have plenty. And now, things that you don't want to forget while you're picking numbers. The first thing is, and this is going to sound silly, but you can't forget to follow the rules. So there will often be things like 3x plus 1 must be even. Don't forget that when you're picking a number for x, that 3x plus 1 has to be even. And also, don't forget to check all the answer choices, because sometimes you'll get excited and one will work, and then if you keep trying them all, another one will work. So you have to check every answer choice, because even if one of them satisfies the requirements, it doesn't mean it's the only one that satisfies the requirements, and then you'd have to pick new numbers to check the ones that are still left.
Why don't we look at a few examples where we can pick numbers?
Okay.
All right, let's pick numbers. I'm going to show a few examples here, and I encourage you to pause the video when you see a new problem, try to solve it on your own, and then push play whenever you're ready to see the explanation. All right, so Diane has X dollars. If Diane gave Eric $5, Eric would have twice as much money as Diane. Now, this is purely hypothetical. It's not actually happening. What is Eric's dollar amount in terms of X? Okay, this is a classic pick numbers problem because we see a bunch of variables in the answer choices. We see a bunch of X's, so I'm going to pick something for X. X represents Diane's dollar amount, and hypothetically, she could give Eric $5, so I'm going to pick something bigger than 5. How about 10? So we're saying Diane has $10, and we want to know how many does Eric have. So in this hypothetical exchange, Diane would be losing $5. Now she would have 5. And it stands to reason that Eric would be gaining $5 from this exchange. Now it says if this went down, Eric would have twice as much money as Diane. So if Diane had $5, Eric would have 10. So what plus 5 equals 10? 5. That's how much Eric has now. So let's see, when we plug in 10 for X, which one gives us 5? 2X, that's 2 times 10, which is 20. Nope, we're looking for 5. 2X minus 5, that's 20 minus 5. 15. Nope. 2X minus 10. 20 minus 10. That's 10. Still no. The answer is going to have to be H. Let's check it. 2X minus 15, that's 20 minus 15. And that is 5. So the answer is H. P, Q, and R are positive integers if P plus Q is even and P minus R is odd. Which of the following must be odd? All right, so we got variables in the answer choices, P, Q, and R, and it's an even-odd algebra question. So those are our clues that we should pick numbers. P, Q, and R have to be positive integers, and I got to start someplace. So I'll start with P equals 2. They say P plus Q is even. So let's say Q equals 4. Then P plus Q would be 6, and that's even. They also say P minus R is odd. So let's say R is 1. And then P minus R would be 1, and that's odd. So let's check the answers and see what gives us an odd value. A, that says P. Okay, we just said P equals 2. Everything checked out. So P does not have to be odd. 2 is even. All right, moving on to B. That says R. Well, R is odd in the scenario that we just drew up. That is 1, so we'll keep B around. Let's check the other answers just to be sure. Q minus P, that would be 4 minus 2, which is 2. That's even, so no, Q minus P does not have to be odd. And then Q plus R, let's see, that's 4 plus 1, which is 5. That is odd. So B and D both gave us odd values, and they're still left on the table. One of them must be odd, and the other one just happens to be odd based on the scenario that we just cooked up. So let's pick new numbers. Last time I started with P equals 2. This time I'm going to start with P equals 3. I did even last time, so this time I'll do odd, and 3 is still small and easy to work with. So they say P plus Q has to be even. Let's do Q equals 5, then P plus Q would be 8. That's even. And of course, P minus R has to be odd. So let's do R equals 2. Then P minus R would be 1. And that's odd. So we only have 2 answers to check. B, that says R. Well, we just said R was 2, which is even. Everything checked out. We followed all the rules. So R does not have to be odd. I think D is going to have to be the answer. Let's see. Q plus R, that would be 5 plus 2, which is 7. Q plus R is odd in both of the scenarios that we just drew up. And it's the only one that meets those requirements. So D is our answer. If Z is an integer and 3Z is odd, how many even numbers are in the range from 5Z up to and including 5Z plus 6? This is an even-odd algebra question, so let's pick something for Z. Z is an integer and 3Z is odd. How about Z equals 3? Then 3Z would be 3 times 3. That's 9, which is odd. Cool. So how many evens are between 5Z and 5Z plus 6? Well, 5Z would be 5 times 3. That's 15. And 5Z plus 6 would just be 15 plus 6, which is 21. So how many evens are between 15 and 21? There's 16, there's 18, and there's 20. That's it. By my count, that's 3. So the answer is A.